Alright, so we're going to pick up where we left off with our video yesterday and start using those basic properties of integrals to do an example today. So we're going to use the properties that we outlined yesterday to evaluate this integral below. And the first one that we're going to apply is property number 2, which dealt with adding two functions together. So if I'm taking the integral of the sum of two functions, and I'm considering these two things here to be my two functions, then instead of representing it this way, I could represent this as the sum of two separate integrals over that same interval. So the sum of the integral from 0 to 1 of 4 plus the integral from 0 to 1 of 3x squared. So I've just used the second property from yesterday to separate those two things. Property 1 is going to make evaluating this first component very easy. So I'm going to use property 1 on this integral because this is just a constant, and yesterday we said that the integral of a constant value is equivalent to that constant times the difference in the interval. So that's that first component evaluated, and we just used property 1 to do that. The second component of this sum, though, I'm going to use property 3, which is going to allow me to remove that constant, which is also the number 3. So it's 3 times the integral from 0 to 1 of x squared. So far we've used 3 of the different properties from yesterday to rewrite this thing. So that first component, 4 times 1 minus 0 is 4. And then I have 3 times the integral from 0 to 1 of x squared. And now I can use one of the properties of our sums from very early on in this unit, where I could rewrite this as 3 times, and I'm going to represent that integral now as the sum from I equals 1 to n of f of some right-handed Riemann sum of x. And in this case, we've got delta x being 1 minus 0 over n, so that's just 1 over n. And our xi is 0 plus I times that delta x, so that's I over n. So what I can do now is I can rewrite this. I've got 4 plus 3 times the limit, and I did leave that out, the limit as n approaches infinity. And I'm going to do the same thing here, the limit as n approaches infinity of the sum from I equals 1 to n of, and now we've got our function, which is I over n, and it's being squared, times delta x, which is I over n. All right, well that, sorry, not I over n, that's 1 over n. Okay, continuing right along. 4 plus 3 times, well, I can remove that constant 1 over n from that sum. So I've got the limit as n approaches infinity of, and I've removed the 1 over n, but I still have the sum I squared over n squared is what that actually ends up being. And I could actually just rewrite that now. Might not be a bad idea. I squared over n squared. Okay, and I need a way to evaluate this. Remember, I can take any constants out of here. There is another constant there. It's that 1 over n squared. So I'm actually going to remove that now, remove one more constant here. So 4 plus 3 times, I've got the limit as n approaches infinity. I've got this 1 over n that's still here, but I'm going to take a 1 over n squared out as well, which is going to leave me with just I squared, which is something I know how to evaluate. That goes back to one of our first units when we were dealing with Appendix E on how to simplify some of these sums that are in sigma notation. I have a representation for that. So this is 4 plus 3 times the limit as n approaches infinity of 1 over, and I can combine those there to 1 over n cubed. And instead of writing the sum of I squared from 1 through n, I can rewrite that as n times n plus 1 times 2n plus 1 over 6. That's an identity from one of our first lessons in this unit. And now I can separate a bunch of these into different components, which is something that we've done a few different times here. So I'm going to distribute or separate these n's to go with some of these different numerators here. 4 plus 3 times, I've got the limit as n approaches infinity of, I'm going to leave the 1/6 by itself, times, I could say n over n, take my first one of these n's and pair it with that n. Then I've got an n plus 1, and I could pair that with one of the n's. And I've got a 2n plus 1, and I could pair that with one of the n's. And so that should take care of each of them. This is a situation where they're going to cancel. I'm going to want to rewrite these two here. So 4 plus 3 times the limit as n approaches infinity, and I still have 1/6 times n over n canceled, but now I have 1 plus 1 over n here, and I have 2 plus 1 over n here. And so now when I actually evaluate that limit, this is going to go to 0, so is this. So I have 4 plus 3 times, I don't need the limit anymore, 1/6 times 1 times 2, which is 4 plus 3 times 2/6, which is 4 plus 6/6, which is 4 plus 1, which is 5. So that's just one example run from start to finish, where you've seen, starting with this beginning integral, we've applied some of the different integral properties that we evaluated yesterday, or that we defined yesterday, and then we used a bunch of our properties of summations to put it all together, and in the end give us the answer to the value of that original integral.